So we'll hop back into Python to look at how we might actually use Word2Vec in a Python example. So we'll import a few more things, some tokenizing functions from our natural language toolkit, just to make our life a little bit easier. And then also this GenSim models, which has these Word and document embedding models sort of built in that we'll use. And also we'll grab requests to grab a article from online. And then finally, a few functions so we can visualize our embeddings. So we can run that. And then the first thing that we'll do is we're going to use the utils functionality from PubMed to get the original enricher paper from its PMC ID. We'll use request to actually fetch that URL, and then we'll just write it to a file. We can then just read in that file and replace the new line characters so that we don't have these escape characters in our text anymore. And then finally, we can actually iterate through our file. So this is where we're going to use our tokenizing functions that we imported from the natural language toolkit. So you can like read a little bit more if you hover over these functions. But basically, we're going to tokenize our input into sentences and then into specific words. And then I'm going to do a little bit more parsing just to remove some additional artifacts, like words that are just one character. A lot of these are just small artifacts from the XML. And then we'll also just remove stop words and then some formatting stuff that is denoted with the slash, like bold and text and whatnot. And we'll append this all to a list of our tokenized sentences that we'll put in data. We can then use our GenSim model to actually create this Word2Vec model here. So we're giving this a few different parameters. So we have our data that we just got from our file here. We have our min count, which basically is just going to say how many times a word needs to appear for it to be sort of considered in the model. In this case, we'll just go with 1 because it's a relatively small sort of corpus that we're working with, just one paper. Then we have our max vocab size, which is relatively self-explanatory. And then our window, which is sort of this context parameter. So how many words are we looking at on either side of a given word? So we can run that and we'll see just a little warning, but nothing to worry about. It's just saying that there's under 10 jobs per worker because it's a very small corpus, like I said. So we can actually print our model here. And we can see that our vocab size is 69. So it looks like there might be missing some words from our actual document there. But our size of our embeddings is 100. So that's that n dimension of the vector. And then alpha is our learning rate. So now with our model, we can do kind of functions like looking at the similarity between two terms. So we'll look at like the similarity between enrichment and set, for instance. And we can see that that's very high, which we would expect in our enricher paper. We can also look at most similar words to a given word. So we'll just look at the top 3 words with enricher, and we see ID and set, and then we also have sort of an artifact in here as well. So definitely could do some additional parsing on that document that we're grabbing from the web to sort of eliminate those as well. It's also worth mentioning that the default is that it will train on this continuous bag of words approach. So you can also initialize this model with a skipgram chaining just by setting this SG parameter to 1. So if we run that, we'll get a very similar sort of printout here where the vocab size and everything is the same, except we've trained it slightly differently. We'll see that our similarity is slightly lower now, but it's still quite high. And then we can also see that it learned slightly different similarities here. So we have like libraries, new methods now being associated with enricher instead of some of those artifacts. So we'll take like a closer look at this second model. So what we can do is we can decompose these 100 length or like n-dimensional vectors into 2 components using PCA. So that's what these sort of lines are doing here. So first we're grabbing those vectors. We're just setting our PCA components to 2, and then we're just fitting that data to those 2 components. We'll just put this in a data frame with X and Y. So we'll graph it on these 2 dimensions. And then we'll also just throw the actual word that these are representing in another column in the table, so that we can actually see what these embeddings are for. You can see we have some more artifacts here, so we definitely can do a better job of actually parsing this document. But finally, we can actually visualize these terms we'll use Plotly and just a scatter plot. So we'll do our PCA-X and PCA-Y as our X and Y. And then we'll also just color the points randomly by just the size of our vocab list. And we'll also set the hover, this text, to the word so we can see actually what these dots are looking like. So if we run this, we can see that we have sort of our enricher, we have new, we have genes, we have a sort of some number denoting it. Human is sort of a part. So you can kind of like see actually where in space a lot of these word embeddings end up. So we have some like of the XML sort of syntax sort of being grouped together, and then some information about from the document like source, author, journal also being grouped together. So this is sort of just one example of using Word2Vec in practice.